All right, guys, are there any questions on 28? On finding the number of positive, negative, and complex zeros? I mean, we can go on and do this here. So to find the number of positive, we just count the number of sign changes. So from 7th to the 5th, that's 1. From the 5th to the 4th, that's 2. 4 to the 3rd, that's 3. Doesn't change. 4th. So the number of positive sign changes is 5. I'm going from one term to the next. Now we can rewrite this because we did it on the last one with replacing x with negative x for every spot that we have it. But one of the main things that we did notice, or that we're ended up doing in the last one, is that if it's the power's odd, the sign changes. If the power's even, the sign stays the same, yes? So we can go through and look at this. Well, the first one is to the 7th power. 7th power is odd, so the sign's going to change. So I can go on and change it to negative 6x to the 7th. So we don't necessarily have to rewrite it with negative x in parentheses all the way through. We just know if the power's odd, the sign will change. If the power's even, the sign won't. The next one's to the 5th, so the sign's going to change from negative to positive. The one after that is to the 4th, so the sign will stay the same. The term after that, the power is odd, so the sign will change from negative to positive. After that, it's even, so it stays the same. 5x is to the 1st, so that's odd, so it's going to change to negative 5x minus 6. So one way to make it a little bit easier, if we know the power is odd, we change the sign. If the power is even, the sign stays the same. So we could have, like on the last one, rewrote. I could have rewrote this. Because I could go through all the way through and replacing x with negative x. Or since we just know the fact that if the power is negative, or if the power is odd, we change the sign. So the first one is to the 7th. It's odd. I'm just going to change the sign. Because all I did was go from here to here. I didn't rewrite it out with negative x in every spot. 7's odd, change the sign. 5's odd, change the sign. 4 is even, stays. 3 is odd, change. So it was positive here. Yeah. This should have been, yeah, so that should have been like that. So I just went through because when I worked this out for this one here, I just went on and changed it. I didn't rewrite it out with parentheses around the negative x. Odd power changed the sign, even power stays the same. And if we count the number of sign changes, well, there's 1. Doesn't change. Doesn't change. 2. No. No, so the number of negatives that we can have at most is 2. So our positive, negative, complex. So the most of each we can have at most 5 positives and 2 negatives. The degree is 7, so we would have 0 complex. And I always start with subtracting 2 from the negatives till I can't anymore. So I can subtract 2 from 2, which would give me, so we could have 5 positives, 0 negatives, and 2 complex. Can we subtract 2 from the negatives again? No. So we reset it back to 2. That'd take 2 away from the positives. So we could have 3 positives, 2 negatives, and 2 complex. Subtract 2 from the negatives again. So we'd have 3 positives, 0 negatives, and 4 complex, because we still need to have a total of 7. Now we can't subtract from the negatives again, but can we continue to subtract from the positives? So we can say 1 positive, 2 negatives, and 4 complex, or 1 positive, 0 negatives, and 6 complex. So these are all the different possible solution sets that we could have. Questions on this here? Any questions on any of this so far? If that brings us to the last set of problems that we have. Solving. Number 29 is the first one with solving. And when we solve any of these here, for this one here, how many solutions am I hoping to find? 5, because the degree is 5. Because if we can find 5 solutions, we're done. So the first thing I would do is graph it. So we can say x to the 5th minus 20x to the 3rd plus 20x squared it is pH. Well, luckily they do give it to us on the graphing calculator. Now, since it is a degree 5, we want to find 5 solutions. But the minimum I want to find by graphing is 2 less than the degree. Since the degree is 5, I want to find at least 3. 2 less than the degree. So we do see that it does intersect the x-axis at 3 places, yes? If we go second table, well, use the arrow key because it'll take. The right way, yep. It doesn't give us so much decimals for the x, but it can for the y value. If in most of those it's giving us decimals, and if you notice it had e to a number, it was just because they're bigger than what they could show. So we do have 3 zeros, 4, 1, and -5. If anything, I do have 3 of the 5 solutions just by graphing it. Any questions on this so far? Yes. So we have 1 for x to the 5th, 0 for x to the 4th, -20 for x cubed, 20 for x squared, -21 and 20. Which one do you want to use first? Huh? 4. Because we just need to pick one and use it. Well, 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. -20 plus 16 is -4. 4 times -4 is -16. 20 plus -16, 4. 4 times 4 is 16. -21 plus 16 is -5. And lastly, 4 times -5 is, which does give us 0. It is. And one of the things I will say, especially on the test, is if one of these values you do see that the graphing calculator tells you that the y value is 0, and you get a remainder other than 0, go back and look at the numbers, because it should give you 0. Next one we can have is 1. 1 times 1 is 4 plus 1 is 1 times 5 is -4 plus 5. 1 times 1 is 4 plus 1 is 1 times 5 is 5. And we need 0. Well, we can do this one more time. And the last solution we had was -5, yes? Well, -5 times 1 is -5. 5 plus -5 is 0. Negative 5 times 0 is 0. 1 plus 0 is 1. And negative 5 times 1 is negative 5. And negative 5 plus 5 is 0. So this is where we got to. Yes? Questions on this so far? So this is our remainder. Constant x squared. So what we're left with is x squared plus 1 is equal to 0. Now this is kind of nice because since we don't have a middle term, we can use the square root method, which just says I subtract 1 from both sides, telling us that x squared is equal to negative 1. Then what can we do next? Square root both sides, telling us x is equal to plus or minus. What's the square root of negative 1? Because I is by definition the square root of negative 1. So we do have plus or minus I. We have 1, 4, and negative 5. I have 5 solutions there, yes? Is that how many I needed to find? So we're done. Questions on this here? We ready for the next one? So let's go on and graph this one. So I can say y equals x to the 4th minus 6x to the 3rd plus 7x squared plus 6x minus 8. So we have these points here, yes? And if we look at the table, well, it tells us that we have solutions at negative 1, 1, 2, and 4, yes? So it's saying x is equal to negative 1, 1, 2, and 4, yes? How many solutions did we need to find? How many do we have? Questions on this here? Questions on any of this so far? Are you ready for the next one? So how many solutions are we looking for this here? 3. At minimum, how many do we need to find? 1. So let's graph it. Y equals. So we have x to the 3rd minus 11x squared plus 41x minus 51. Well, they gave us exactly 1. And our solution is 3. So we'll have 3, 1, negative 11, 41, negative 51. Then we can work this out. 3 times 1 is 3. Negative 11 plus 3 is negative 8. 3 times negative 8 is negative 24. Negative 41, or 41 plus negative 24 is 17. 3 times 17 is 51, which does give us 0. Unfortunately, we do have a middle term for this here. So this is our remainder. Term without x, term with x, term with x squared. So we have x squared minus 8x plus 17 is equal to 0. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, we're going to plug this in and simplify. Well, the first part we have is negative b, yes? What's the value of b? Well, b is negative 8, yes? So what do we have? Negative, negative 8. Negative and a negative make a negative 8 squared minus 4. Value of a is 1, and the value of c is positive 17. Questions on this so far? What did we say a was? 1, yes? So on bottom, 2 times 1, which is 2. Negative, negative, I make b negative, and we do this here. Now we can type everything inside the radical into the calculator. So we still have square root. So quit. Negative 8 squared minus 4 times 1 times 17, and we get negative 4. Well, the negative is going to come out as I. Negative is going to come out as I, which leaves us with the square root of 4. What's the square root of 4? Well, both of those numbers, are they divisible by 2? 8 divided by 2 is 4, and 2i divided by 2 is I. So x is equal to 3 comma 4 plus or minus I. Questions on this here? And if it already, like the last one, it gave you all of them, you're done. Questions on this here? Any question on any of this so far? If we look at this one here, is there a greatest common factor between these two? Well, they both have a common factor of 9m cubed, yes? And the reason I say this is because if we factor 9m cubed out of 9m to the 5th, I'm left with m squared minus 27 divided by 9 is 3, and the m cubed factors out completely.
May I have your attention? Will Olivia James and Chris Johnson please go to the library at this time? Thank you.
Now this here equals 0. So we have two things multiplied together to equal 0, so one of them must be. So we're saying m to the third is equal to 0. We're also saying m squared minus 3 is 0, yes? Well, for this one over here, we can add 3 to both sides, telling us m squared is equal to 3. Then what can we do? We can square root, telling us m is equal to plus or minus the square root of 3, yes? M to the third equals 0. Well, that's really just telling us that m is equal to 0, yes? Well, how many m's do I actually have here? 3, yes? So it also means m is equal to 0 and m is equal to because the degree tells us the number of solutions, so it should have 3, and they're actually all 0. So the solutions for this here is m is equal to 0, 0, 0, and plus or minus square root of 3. Questions on this here? We have 2 left, don't we? We'll go on and finish those 2 out, and we'll be done. 33. Again, first place I'd start is graphing. So the degree is 3, so how many solutions would be nice to have? 3, but we're hoping for at least 1, yes? So I can type it in, 3x to the third.
Joshua Kramer, please go to the library.
Plus x squared minus 38x plus 24, yes? And if we hit graph, how many solutions do we have? Well, we have it crossing at 3 places, yes? How many of them are nice? Two of them, because I have 1 at -4 and I have 1 at 3, yes? So we can use those. Three for x cubed, 1 for x squared, -38, and 24. And we said x is 3 and -4. Which one of those two do we want to use first? Doesn't matter, we just got to pick one. 3. And we can do our synthetic division. 3 times 3 is 9. 9 plus 1 is 10. 3 times 10 is 30. -38 plus 30 is -8. 3 times -8 is -24, and 24 plus -24 is 0, yes? Do we have a quadratic? Well, yeah, I could use the quadratic formula at this point. But do we have another solution? Yeah, we have -4. I would do this here because we're going to take it from a quadratic down to a linear. -4 times 3 is -12. 10 plus -12 is -2. -4 times -2 is +8. Then -8 plus 8 is 0. Questions on this so far? Hopefully, yes. Question? If we plug the variables back in, well, that's the remainder. -2 is the term without x. 3 is the term with x. So we're saying that 3x minus 2 is equal to 0, yes? Now we just need to solve for x. So what can we do first? We can add 2 to both sides. Telling us that 3x is equal to 2. And then what? Divide both sides by 3, telling us x is 2/3. Well, we also know that x is equal to 3 and -4, yes? Because if it can give me all the solutions by graphing, that's the best option. If I can get all but one, that's quite nice as well. But I need at least 2 less than the degree. Questions on this here? We ready for the last one? Yes. Well, we're looking for how many solutions? 3. We need at least 1, but it'd be nice to have all 3. So I'd start off by graphing. 4x to the third. Minus 49x minus 60. Graph. Well, we do have one nice number at 4, yes? And we can look at the table. And we do see when x is 4, the y value is 0. So we do have one solution so far. We can set up our synthetic division. 4 will go in the cubby hole. We'll have 4 for x to the third, 0 for x squared, negative 49 for x, and negative 16. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. Negative 49 plus 64 is 15, and 4 times 15 is 60, which does indeed give us 0. Now, if we plug the variables back in, we have our remainder. 15 is the term without x, 16 is the term with x, and 4 is the term with x squared. So what we have is 4x squared plus 16x plus 15 is equal to 0. We could try factoring this if we want, or we can just plug it straight into the quadratic formula. Either way works. So we'll have negative b, so that'd be negative 16, plus or minus the square root of 16 squared minus 4 times a, which is 4, times 6c, which is 15, all over 2a. 2 times a, well, a is 4, and 2 times 4 is 8. So inside the square root, we have 16 squared minus 4 times 15. So in either calculator, we can say 16 squared minus 4 times 15, yes? Which gives us 16. Well, we can take the square root of 16, yes? Square root of 16 is 4. Can we add negative 16 and 4 together? Can we subtract them? Yeah. So we'll need to simplify this here, because really what this is saying is that x is equal to negative 16 plus 4 over 8, and x is equal to negative 16 minus 4 over 8. So we have these two here. And this is kind of nice in the calculator, is I can do fraction negative 16 plus 4 over 8 and hit enter. And we get negative 3/2. I can come up, select it again, and change the plus to minus, and we get negative 5/2. So we get both, negative 3/2 and negative 5/2. So in this here is equal to negative 3/2, and here x is equal to negative 5/2, which tells us our solutions are x is equal to 4, comma, negative 3/2, comma, negative 5/2. And that's it. Any questions on any of this here? Any questions on any of this here?